Good morning, everybody. Today we are going to be talking about ventilation requirements for underfloor spaces in commercial buildings. These are also commonly referred to as crawl spaces, but the code term that we're going to be using is the underfloor space. So we're going to be talking about how to vent these underfloor spaces. It's a little bit of a complicated topic. And it's one that doesn't get a whole lot of discussion time, so it's important for us to go over this today. And we're going to start by, let's see, here we go. Talking about the importance of ventilation. So in concealed and closed off spaces, such as underfloor spaces, crawl spaces, if the air is not allowed to move or cycle in and out, the air will become stagnant and negatively affect the building. This includes things like excessive temperature and humidity buildup, accumulation of biological growth and unwanted gases, and potential damage to various building components. So we're going to be relying on the 2018 edition of the International Building Code, as well as the commentary. And the underfloor ventilation regulations can be found in section 1202.4, which reads, the space between the bottom of the floor joists and the earth under any building, except for spaces occupied by basements or cellars, shall be provided with ventilation in accordance with section 1202.41, .2, or .3. So first thing to note is obviously this does not apply to basements or cellars. The reason that's the case is because basements and cellars are intended for human habitation. People will occupy those spaces. Crawl spaces, on the other hand, or underfloor spaces, on the other hand, typically are not places where people will be inhabiting the space, other than for very short periods of time for maintenance operations and whatnot. But the crawl spaces are usually, they're not a place where people are hanging out, so it's not. That's why the provisions for the ventilation apply to crawl spaces, but not basements or cellars. So let's see what the commentary has to say. It says the intent of section 1202.4 through .44 is to create an adequate flow of air through crawl spaces to achieve the ventilation goals of controlling temperature, humidity, and accumulation of gases. The idea being, if you don't control those things through proper ventilation, you are going to have negative effects on your building related to temperature, humidity, and the accumulation of gases. Going on, the entire space must be properly ventilated by openings that are distributed to affect cross flow and include corner areas. Although the code does not specify the exact location of openings, an equal distribution of openings on at least 3 sides of a building with at least 1 opening near each corner of the building is typically sufficient. So you'll note that the commentary correctly points out that the code does not specify these locations. This is where the judgment of the design professional comes into play. It's up to the engineer or architect who is designing the ventilation system to make sure that they do achieve cross flow. Cross flow is very important when it comes to properly venting a space. As we'll see going forward, if you don't cross ventilate the space, you have the higher potential to create dead zones under the floor where air will remain stagnant and not ventilate properly. So cross flow is very important. Let's see here. The ventilation must comply with one of the methods provided by sections 1202.41, 2, or 3. Those are the 3 that we're going to go over today. Ventilation in flood hazard areas must also comply with section 1202.4.4. We're not going to cover that one today. We're just going to cover the first 3. So let's start with 1202.4.1. This is what we call the passive or natural ventilation option. And this is where you actually just construct openings in the crawl space to allow air to freely move in and out. So here's what this code section says. Ventilation openings through foundation walls shall be provided. The openings shall be placed so as to provide cross ventilation of the underfloor space. The net area of ventilation openings shall be in accordance with section 1202.4.1.1 or 1202.4.1.2. Ventilation openings shall be covered for their height and width with any of the following materials, provided that the least dimension of the covering shall not be greater than 1/4 inch. And then it gives you a list of grates, louvers, plates, other sorts of things that will allow the air to move in and out. So the part that reads that the net area shall be in accordance with section 4.1.1 or 4.1.2. We're not going to go over those specifically, but what those basically are different formulas depending on whether or not you have a protected ground cover over the floor of the crawl space. Now, interesting, in the 2018 code, which is the code we're reviewing, this section opens up by providing the requirement for the cross ventilation. You can see it's the second sentence. Openings shall be placed to provide cross ventilation. Interestingly, in previous code editions, 2015 and earlier, you see that the requirement for the formula rather for the net free area, which is the equivalent of 1202.4.1.2, that section in earlier code editions gives you the requirement for the vapor retarder and cross ventilation. It actually says you have to do both. And that's that exception under older codes. The 2018 kind of switched it up a little bit by requiring as a basic requirement the cross ventilation. So the idea is you can't just have vent wells all concentrated like on one side of the crawl space. Even if you provided the requisite free area of ventilation, if they were all combined in one small spot, you're not getting cross ventilation, and you're not going to achieve a properly performing crawl space. So it's important to note vapor retarder is one component of a reduced net free area, but only in combination with a properly cross ventilated space. And the photograph you see here is an example of a vent well outside of a building. So that ventilation well opens up into the crawl space below and allows the air to move in and out. So the commentary to this section reads, crawl spaces that are intended to be naturally ventilated to the outdoors must comply with this section and section 1202.4.1.1, where the crawl space has open earth floors, or with this section and section 1202.4.1.2, where the crawl space has covered floors. So that's, we just talked about that a little bit. It has to comply with that base section for cross ventilation in addition to those other requirements. And then, of course, it talks about the reason that you limit the openings to 1/4 inch or less is to keep animals from being able to go in and out of the building. And this photograph is an example of a vent well as viewed from inside a commercial crawl space. 1202.4.2, and interestingly, in the 2018 code, this now has its own section. Under previous code editions, this section for ventilation in cold climates was actually covered by an exception to the general requirement for ventilation. But it was important enough that in the 2018 code, they went ahead and made it its own section. So what this says is ventilation in cold climates, in extremely cold climates, where a ventilation opening will cause a detrimental loss of energy, ventilation openings to the interior of the structure shall be provided. And so the idea here is, instead of venting to the outside, where if it is an extremely cold climate and it's freezing outside, if you allow that air to circulate through the crawl space, you could be negatively affecting the energy performance of the building. And so the code now recognizes that in these circumstances, that it is an acceptable alternative to actually vent into the building. So you can vent into the interior of the building and then allow the crawl space to basically breathe in and out through the interior of the building. And so one very important thing to consider is if this is the method of ventilation that you're proposing for any of your projects, make sure your mechanical engineer is aware of the potential of additional temperature and humidity loads that will be imposed on the building's HVAC system. Because again, in this circumstance, you're not providing mechanical conditioning or mechanical outdoor ventilation into the crawl space. You're simply allowing the area of the crawl space to vent into the interior. And so there are some additional considerations as far as humidity and temperature loads that would be prudent to consider, or have your mechanical engineer consider, just in case this necessitates additional conditioning capacity to handle the underfloor space. So this photograph is it's a duct penetrating the floor above, and it's open into the underfloor space below. This is a systems similar to this one can be used to connect the interior air to the underfloor space per this section of the code. Next, let's talk about 1202.4.3, mechanical ventilation. So mechanical ventilation is different from natural ventilation in that we're now relying on forced air movement through the use of ductwork, fans, HVAC, potential conditioning, potentially not. We're going to cover both of those in these two subsections, but the main mechanical ventilation section reads that mechanical ventilation shall be provided to crawl spaces where the ground surface is covered with a class 1 vapor retarder. Ventilation shall be in accordance with subsection 1202.4.3.1 or 0.2. Now, again, in the 2018 code, this is a little bit different than how it read under previous code editions. If you review the ventilation section from the 2015 code and earlier, you'll see that the requirement for the vapor retarder was actually specifically noted in the exceptions. And it's kind of funny because it's a little redundant now. The vapor retarder is noted in the base section for mechanical ventilation, but then it's also noted a second time under the mechanical ventilation subsection 0.1. Here's what that says. Continuously operated mechanical ventilation shall be provided at a rate of 1 cubic foot per minute for each 50 square feet of crawl space ground surface area, and the ground surface shall be covered with a class 1 vapor retarder. So it's a little redundant because the base section already says the ground surface is covered with the class 1 vapor retarder. That's a holdover from the previous code editions in which the class 1 vapor retarder requirement was only found in the subsection, not in the main section. That was a source of confusion for many people who didn't think you actually need a vapor retarder if you're doing mechanical ventilation, because it wasn't always clear that that was a requirement, a base requirement for mechanical ventilation. That's now cleared up in the 2018 codes and onward. It is a requirement. If you're doing mechanical ventilation, you have to protect the floor. And the reason you have to do that, which is actually evidenced in this photograph, shows a vapor retarder on the ground, and you can actually see in this photograph the moisture below the plastic. And the caption says a vapor retarder keeps the moisture from being drawn into the space, helping to keep the underfloor space dry. So when you have a mechanical system venting the crawl space, essentially that forced air movement is a continuous draw out of the soil. So you're going to be continually pulling moisture out of the ground. And because of that, the code needs to protect that from happening. The whole point of venting the crawl space is to help keep it dry. And so if you are introducing a system that is going to be continually drawing moisture out of the ground, then it only makes sense that provisions to control that moisture are put in place. And so this is why the vapor retarder is required. It keeps that moisture under the plastic. It keeps it from affecting the space, increasing the humidity of the crawl space and other things like that. So the second exception, it's not an exception, the second subsection, 1202.4.3.2, talks about conditioning the crawl space. Now, this is different from ventilation. Conditioning the space is also ventilating the space, but it's also heating and cooling it. So if you condition the crawl space, in essence, you're treating the crawl space as any other part of the conditioned building. You're going to heat it in the winter, you're going to cool it in the summer, you're going to run AC to keep it cool and dry, you're going to heat it when it's cold outside. That is sufficiently different from just a regular ventilation solution because the continuous mechanical ventilation solution, what that does is it's basically pulling air from outside through fans or mechanical components, and it's pushing the air out. It's exhausting the air back to the outside via mechanical means. So the mechanical ventilation is still venting the space to the outdoors. You're pulling the outdoor air in and you're pushing the outdoor air out versus conditioning the space. If you condition the space, you'll note that this code provision requires the walls of the crawl space to be insulated in accordance with the Energy Conservation Code. And the reason why that's the case is again, because now you're treating the crawl space as part of the conditioned interior area of the building. And so then to the same degree that you would insulate your exterior walls in any given building, now you have to insulate the exterior walls of the crawl space because you're conditioning that space. So very important to know if you are proposing or designing a mechanical conditioning ventilation system for the crawl space, make sure you insulate those walls. It's not mentioned in this section, but if you don't condition the space and you just vent it, then you are still required to insulate the floor, but not the walls. In this case, the floor above, meaning if you're in the underfloor space, you're standing in the crawl space and you're looking up, you're looking at the underside of that floor. That floor is the boundary of the thermal envelope in that circumstance. And in that circumstance, then you would have you'd have to comply with the floors over unheated spaces per the IECC. So regardless of which system you use, natural ventilation, passive ventilation, mechanical ventilation, or conditioning, you do need to make sure you consider the which one of those systems results in what type of thermal boundary to the building, and make sure you insulate those perimeter spaces accordingly. And of course, make sure you understand the difference between mechanical ventilation and mechanical conditioning. We did briefly just go over that, but again, the conditioning requires insulation of the walls. The ventilation would require insulating of the floor. And again, a vapor retarder is required when either of these ventilation options are proposed. So here is an example of an insulated floor, indicating the thermal envelope is the floor assembly. In this particular scenario, the underfloor space should either be naturally vented or mechanically vented, not conditioned. Because again, if you're conditioning the crawl space, then why would you insulate the floor? You have conditioned space above, you have conditioned space below. There's not going to be, you're not anticipating a temperature delta or a humidity delta between the two spaces, so you don't need to protect the assembly that separates the two spaces. If you're going to do a conditioned crawl space, this drawing, this CAD drawing represents insulated crawl space walls. In that particular case, again, you're conditioning the space, you're going to insulate the walls and the vapor retarder included on the ground. Here's another example of insulated crawl space walls protecting the outside from the inside. And such a scenario like this suggests mechanical conditioning of the space, not necessarily simply ventilation. So this is the importance of ventilation. What happens if you get this wrong? If you don't properly vent the crawl space or the underfloor space, you're going to get a buildup, or you can expect to get a buildup of temperature and humidity, and that can result in condensation, such as what this photograph depicts, condensation on the inside of the foundation wall. And you can also see the condensation forming on the underside of the metal deck. That this sort of condition can negatively affect the systems that are in the crawl space. You can see some corrosion on the pipe hanger right there. Obviously those penetrations as well through the floor. You're going to get increased humidity pushing through the floor system, potentially negatively affecting the space above. Condensation on the underside of the concrete. In this particular example, you can see that the buildup of humidity results in condensation forming, which keeps the floor wet. Another example of that happening, lots of condensation. Another example. So in situations like this, where if you have a concrete floor and you're not controlling the humidity levels in the underfloor space, the concrete is at risk of becoming saturated with moisture and being essentially a continuously wet floor. Now, what does that do to the top? So in this particular circumstance, there you can see some damage to the top of the slab. You can see the staining. You can see some white efflorescence forming on the top of the slab. And essentially what's happening is, even though you have a vinyl tile here, you have vapor drive pushing upwards through the slab. Because you have a temperature delta, you're cooling the interior. You've got air conditioning running above the floor, and so you have a colder space above, and you have a warm, humid space below. That difference is going to encourage vapor drive and moisture drive up through the floor system, where in this particular case it gets trapped under the floor tile, but manifests as efflorescence, or in some cases that vapor drive can actually push through the concrete, cracking the concrete, cracking the floor tile above. You can actually see where this floor tile was pulled, the tile above it in the photo is cracked. And so that crack was formed when all the moisture under the floor was driving through the concrete. Once a crack forms, the vapor just pushes through it. The humidity starts to push through it, and you can see there's a significantly moisture stained crack forming in the concrete, and that is pushing moisture through the floor. In this particular case, resulted in damage to the floor tiles, as well as damage to the concrete. Another potential problem, if you get the ventilation wrong, is corrosion of exposed steel, where the crawl spaces are constructed of steel components. Corrosion is a concern if you're not keeping it dry. And lastly, in this particular instance, the cardboard void forms are wet and exhibiting evidence of biological growth and rot. That's obviously not good for the air down there, and to the degree that there are openings, penetrations, joints, or seams in the floor system that can allow that air to move into the space above, you really want to make sure that you don't have stuff like this happening, because that can negatively impact the air quality above. So there you have it. That is a quick rundown of why ventilation is important in commercial underfloor spaces, and 3 primary ways that the building code allows you to address that. So with that, I want to thank you for watching, and please like and subscribe if these videos are of interest to you. Thank you very much, and we will see you next time.